Hi, I'm Alice Roffi. I'm research fellow at the University of Florence in the field of STEM education supported by digital technologies. I have a master's degree and a PhD in the biological field and also a PhD in educational sciences. In this video, we will explore the benefits of another student-centered strategy, the problem-based learning or PBL, focusing on the features of this teaching strategy and exploring the educational benefits in the context of STEM teaching for higher education. Let's start to explore the PBL method. Problem-based learning, or PBL, is a student-centered strategy in which the students are involved in the active construction of their knowledge through the solution of real-life problems. This strategy, based on Dewey's theoretical principle of investigation and discovery, began to spread in the American context in the 70s, initially in the field of medical training and then in all scientific disciplines. There are different models for PBL, but according to Smith and collaborators, the key characteristics are the nature of the problem, the context in which the problem is embedded, the integration of different subject areas, a learning-centered approach, as I already mentioned previously, teacher as the guide or facilitator of the learning process. Regarding the nature of the problem, a central aspect in this strategy, there are several types of problems according to Jonathan, and they can be described on the basis of 4 dimensions. The first dimension is the degree of structure, a parameter that indicates the definition of the problem. It could be well or ill-defined. Well-defined problems are mathematical problems, for example, that require the application of a few specific concepts with a unique solution. On the contrary, ill-defined problems have several solutions and some aspects that are unknown, as in the case of designing a project or a strategy. In the medical field, for example, an ill-defined problem could be a diagnostic problem. The second dimension is the complexity, that is the number of variables involved and their relations. According to this definition, it is clear that the ill-defined problems are more complex than well-defined ones. We move to the third dimension, the dynamism. This dimension refers to the environment in which the problem is inserted, which changes over time, leading the students to have to rethink new solutions. Finally, the last dimension is the context. We say that the focus of PBL is the learning in real context. Consequently, the context represents the characteristics that influence the definition of problem and its solution. To recap, the 4 dimensions that define the nature of a problem are degree of structure, complexity, dynamism, and context. The combination of these dimensions are important to shape the problem on the basis of the context, student characteristics, and the specific requirements of the different disciplines. Since the PBL is student-centered approach, adequate support is essential. Students are actively involved in solving undefined and authentic problems, taking greater responsibility for their learning. In this perspective, teachers acted primarily as facilitators rather than frontal transmitters of knowledge. Their role includes guiding the process of problem analysis and synthesize ideas, as well as providing constructive feedback and support. Peer collaboration is a cornerstone of PBL, with students working in groups to address challenges. In this perspective, group size is an important characteristic influencing the effectiveness of the interaction. For this, teacher needs to carefully evaluate the group size on the basis of the context constraints. The use of instructional scaffolding is also suggested to help students develop skills such as critical thinking. The integration of different resources and tools, including digital media, videos, and mind maps, for example, assist students in organizing information and solving problems effectively. This integrated support system is crucial to maximize students' engagement and learning in problem-based learning. The literature reports positive effects of PBL on students' learning improvements, problem-solving skills, attitude towards scientific disciplines, and critical thinking development. Problem solving is a key ability for students, permitting them to learn concepts to solve problems. A research by Liu and Pastors underlined that PBL is effective in fostering critical thinking, especially when used for teaching science disciplines, both in terms of skills development and the disposition to acquire such skill by encouraging analytical reasoning and problem solving in higher education contexts. Critical thinking includes the ability to formulate hypotheses, design and conduct experiments, and also scientific and quantitative reasoning. Various factors have been found to affect how successfully PBL promotes critical thinking. These include students' maturity, nationality, type of education, and group size elements that should be considered when implementing problem-based learning approaches. Moreover, students involved in PBL report greater academic engagement and commitment, supported by the active nature of participation and the significance of their input toward collective goals. Positive experience with PBL are also linked to the student perception of a strong intrinsic motivation and self-efficacy regarding their scientific abilities. According to a study by LaForce and colleagues about PBL-based university initiatives, these aspects are strong predictors of students' increased interest in pursuing STEM careers after high school. PBL environments also promote the development of further skills, including collaboration, communication, creativity, reflective thinking, and self-directed learning. Ultimately, PBL demands a high degree of student engagement, enabling the development of knowledge and skills beyond the subject matter itself. Finally, to underline the potentiality of problem-based learning in promoting also transversal skills, a recent study by Lucina and colleagues investigated the students' perception about the impact of problem-based learning in forest science education. They, in fact, reported the improvement of different types of skills, from those related to technical knowledge to those referred to collaboration, communication, and interpersonal skills. In conclusion, problem-based learning offers a powerful approach in higher education, engaging students in constructing their knowledge and promoting learning and the development of further skills such as critical thinking, analytical reasoning, also increasing the interest in future STEM careers. In the next video, the aspects discussed here will be faced from a practical perspective, looking at how problem-based learning can be implemented in STEM teaching. Thank you for watching this video.